Hello, we are at the Postal Museum store in Essex and I am stood next to our subject for today, a TV detector van. In past decades, these things patrolled the streets of Britain attempting to catch households watching public broadcasts who hadn't paid up for their TV licenses. Now that's as far as I'm going to go in terms of general information on these things. If you are wanting to know more, I will leave some links in the description. Our actual objective today is to test the prominent methods that these things use to supposedly catch viewers watching broadcasts unlicensed, red-handed. Now all of that testing is going to be done back at my place with my own equipment, but later on we will be having a look inside this van to see what sort of detection goodies are contained within. So let's get into it. Before we get started, a quick disclaimer. This video is only going to cover the detection of viewing of analog broadcasts on cathode ray televisions. We will not be talking about enforcement of digital television licensing. Today we are going to test two different detection mechanisms. The first and earliest used is the detection of line scan. Put simply, vans would attempt to pick up the electromagnetic fields created by the horizontal scanning process. These fields were created by large electromagnets mounted around the tube of the television, which steered the beam across the screen. Now, it doesn't take a genius to work out that electromagnets of that size, driven with that kind of power, are going to create emissions. But just how detectable were they? The signal vans were looking for was a sawtooth wave at either 10.125 kHz for 405 line monochrome sets, or 15.625 kHz for 625 line color sets. Despite having a pretty reasonable collection of electronic test equipment, I don't have anything which can detect line scan, so I had to build something. My receiver is based on the same principles of the earliest detector van designs, using a beat frequency oscillator. I went down this path because I was interested to try to recreate the experience of operating one of the early detection vans. Now the concept here is pretty simple. The line scan frequency is collected by an antenna, then heterodyned with a local oscillator set 1 kHz above the line scan frequency, which results in a 1 kHz tone, a beat frequency, when a TV of the relevant standard is detected. Now one of the things I expected to have trouble with in making this is antennas, and they definitely were a problem, so I actually ended up building two. So this here is a high impedance loop, this is a low impedance loop. Now these things are fundamentally different and they have different characteristics. So what I found with this one is that it was very easy to construct and it works really well. So I've got a little preamplifier at the top there which just gets us to a reasonable level of output. The problem is that it's not really all that tunable and the range of it is limited to around about 6 meters. I just couldn't get anything more out of it. So having done a bit of research, the people who are really serious about detection of low frequency signals at distance, they use a low impedance antenna like this one, and this one is copied from a design that I saw on the W1VLF channel. He has lots of amazing videos on how to construct these things there. Now this one does work, but what I found is that getting this thing to be optimum and actually working at a significant distance was going to take a whole lot of extra effort, and I've already spent a lot of time on this video and I don't really think it's going to add a lot of value. The theory behind these things is well proven, so I think we'll just put that one aside for now, but maybe sometime in future I'll have a look at it. So this here is our receiver. Now you don't need to tell me that we can do lots of cool things cheap and easy with software defined radios, I know, but each once in a while I'd like to just build something all analog. I find it really satisfying. So I've put this together in blocks just to make it easier for me to build and test, and also easier to break up and scrap for other things once we're done with this video. So let's have a look at all the various parts of it here. Our power supply is a linear toroidal transformer just to keep things nice and clean. The signal comes in from the antenna on this cable here into the mixer section. So this one combines the local oscillator, which is this one here. This one is going to be the one that's 1 kHz above the line frequency. Now for the demo I'm actually going to use my benchtop signal generator because it's a bit more stable than this one, but at a pinch this one does work. So after the signal has been mixed, we have the 1 kHz tone coming out of the output of the mixer, and this will also contain the input signal, which we don't really want. So that then heads into our audio output assembly here, which contains a low pass filter. That's a cell and key filter because I'm lazy. After that, we have a final stage amplifier to drive the speaker, and that's it. Dead simple. Volume control here, which is basically useless because I just always have it turned up to the max. Our test signal setup today is exactly the same one that we used in the previous video. Check it out if you are interested. The only thing that we're going to be doing differently today is no VHF testing. Now, I was originally considering to add it, but I couldn't find a VHF antenna, and I don't think it would add all that much value anyway, because we will be testing UHF, which is way harder. Okay, so we are up and running here aside from our television, and right now we're not hearing anything coming out of our receiver, and that's because there's no sources of electromagnetic radiation in this room that this device is attuned to. So let's go and switch on our television. Haha, I love the sound of that thing powering on. So straight away, that's our 1 kHz tone that I was talking about. So that is the beat frequency between the oscillator on our receiver and the line scan frequency. Now, sitting around listening to a 1 kHz tone doesn't really sound all that exciting, but having gone to the trouble of building this contraption, I'm finding it really interesting. And the reason for that is because it tells us that there is a source of exactly 10.125 kHz somewhere nearby. And back in the old days, that realistically is only going to be happening if somebody is watching a public broadcast on a CRT television. Allow me to demonstrate. So if I turn off our channel converter here, the TV will lose its signal. And notice that that has just shifted a little bit. So what's happening is that the line scan process in television is still running, but it's free running now. So it's not locked to an incoming signal. So it's kind of just drifted off a bit. And the pitch coming from our receiver is noticeably different. And this is a key important point. So the van operators would be very attuned to that very specific 1 kHz frequency. If they hear something that's kind of close to 1 kHz, but not really, they know straight away that whatever's going on here is not somebody watching a public broadcast, so they can move on. Switch that back on. There we go. Now, the other interesting thing that I've read is that the radiation coming from the sets is highly polarized. So the electromagnetic waves are sweeping across the room in a kind of horizontal motion. And that's the reason that we hold the antenna in this particular orientation, because it excites the elements within it and we actually get a current coming out of it. But if I rotate it around, notice straight away that we kind of lost it a bit there. We just have some other general noise coming from the room. So that does confirm what I've read in that it isn't definitely highly polarized. And that makes me wonder if there's a little hack that we can do to give those vans the slip. So if I just switch off our TV, rotate it on its side, switch it back on again. So now we kind of don't really detect it so much unless I rotate the antenna at 90 degrees, which is pretty interesting. And that does conjure up the rather interesting possibility of household people sitting around on their sofas like this, and the vans driving past like this. Nice little tip there to give them the slip. Unfortunately, it's only 60 years too late. But anyway, let's move on to our next experiment. So as promised, we're now going to test 625 lines, so let's switch on the telly. So for this experiment, the local oscillator frequency on the receiver has been increased to 16.625 kHz, and that is once again exactly 1 kHz above the 15.625 kHz line scan frequency. And straight away we can hear that 1 kHz tone, so working just as well. And of course I've selected test card F for this most British of subjects. Now in terms of signal strength, I've seen it written that these later colour sets emitted less radiation than the old 405 line sets. My finding here is that this one is actually emitting slightly more radiation. Certainly I seem to be still getting a good signal even way out here, sort of 3 meters away, which is actually a bit better than the 405. But it doesn't help that my 405 line set is minuscule. I'm sure if you had a big old-fashioned beast, it would be way stronger. But anyway, this mechanism does clearly also work for 625 line, although from what I've read it wasn't used so much. They had moved on to other mechanisms which we are going to be testing shortly. The mechanism in question is local oscillator detection. The original line scan method was said to have been abandoned due to various increases in interference and the arrival of additional broadcasters. Instead, the vans went after the emissions from the oscillators within the tuning systems inside of television sets, which can theoretically give detection vans a clear indication not only that a television is present, but which channel it is tuned to. To receive a signal, a TV uses two local oscillators to heterodyne the input signal down to a baseband signal. The second, aside from some rare exceptions, can be assumed to be fixed at 38.9 MHz, thus isn't all that interesting to attempt to detect. The first LO is the one of interest, the one which changes when a viewer changes the channel. To calculate its frequency, we simply add 38.9 MHz to the center frequency of the channel in question. In this example, I'm using channel 21 at 471.25 MHz, as it is the lowest frequency which could carry colour television in the UK, thus it is common for testing. Working against the vans is that the amplitude of these oscillators is minuscule, and in the case of the first LO, the one we're looking for, it's trapped inside of a tuna can. Personally, I'm a little skeptical that this mechanism is actually feasible. Now what we're going to do first is try to prove the concept of local oscillator detection, and for this I have our Sherman demodulator, which I told you guys all about back in the demodulators video. Now this is a professional piece of equipment. It spent its working life monitoring on-air broadcasts. However, it is actually built out of the same components as a consumer television, and it's in a nice clean format that I'm not going to electrocute myself on, so we're going to use this. Now what we're looking for first is that 38.9 MHz second local oscillator frequency, so we're just going to run around the circuit board with this probe and see if we can spot it. Now it's not actually immediately jumping out at me. I expected it to be quite strong, but I'm not really. Maybe that's it around there. I expect it to be somewhere around this section. I think that's it there. Very, very faint, and this is probably another oscillator for demodulating audio, I would guess. So yeah, it's there, but it's really, really faint. Actually, I don't think that would really be able to be detected from a distance. So that's interesting, and that I wasn't expecting that actually. So the next thing we want to try and find is that first oscillator, and that's actually the useful thing to find, because that's actually going to tell us whether or not this is tuned specifically to channel 21. So let's punch in the center frequency, which is 510.15 megahertz. Right, let's see if we can find that. Nothing. Nada. Oh, actually no, there is something. Whoa, hey, look at that. Whoa. Clear as day. Look at it, there it is. That is a 510.15 megahertz tone. Clearly detectable. I was not expecting that. Way more detectable than the second local oscillator, and this is the one we want to detect to catch these people. So there it is. Now, just to double check that I'm not kidding myself here, let's disconnect the antenna and see what happens to that. Ah, yeah, that's definitely it. So what it's doing now is it's hunting to try to find the signal, because it's got the automatic frequency correction turned on. So yeah, so if we plug the input back in again, should find it pretty quickly and lock. Bam, just like that. That's pretty good. So I feel like it's definitely worth getting out our television and seeing if we can detect it coming out of the back of that. For our CRT, we're just going to probe around the back and see if we can find that same tone anywhere. Nothing. Nothing. Oh dear, that's disappointing. I can't find anything. Oh, hello. Is that it? Let's try and get in a bit closer here. Somewhere around. Haha, yes! There it is. That is the 510.15 megahertz local oscillator tone. It's very, very faint. I'm seeing it at sort of negative 90 dBm here, which is almost nothing, barely detectable. But this antenna here is not really very high gain. So that's interesting. I think we have cause for a trip to Screwfix to go and buy an antenna and actually test this outside to see if we can actually detect this at range. Maybe we can. After a quick trip to the local hardware store and a reminder of how large outdoor Yagi antennas are, I put together this little setup here just to check whether or not we can detect that local oscillator tone through it from the other side of the room. So having fiddled around with the spectrum analyzer a bit, I've eventually managed to find our local oscillator tone, but it's very, very faint. Look at that, negative 110 dBm. It's almost undetectable. It's virtually nothing, but it is just there, and I can prove that by changing the TV to a different channel. So if we change it to something else, it disappears. So you can see clearly now that it's gone. So we'll bring it back to channel 21, and there it is, it's back again. So we have been able to detect it from across the room, but yeah, I don't like the chances of actually doing this through a brick wall and from, you know, maybe 10 to 15 meters away. Feels a bit unlikely to me. And there is another problem here that although I've got the center at 510.15, which is what we're expecting, it's off. Now we have a span of only 500 kilohertz here, so it's not off by much, but it's definitely off. So one of the problems with this mechanism is that the second local oscillator frequency has to be exactly 38.9 for that to be exactly 510.15, and inevitably it's going to be a little bit off. It's going to drift around, so it does make the gathering of evidence a bit shakier here. But I feel like it's definitely worth trying this outside. I feel like there's some chance of it succeeding, but yeah, hopes for the enforcers here feel like they are diminishing, unfortunately. Now, I don't know about the UK average, but most houses in my street seem to have a distance of about 10 meters between the front wall of the living room and the curbside. For whatever reason, we're actually about 25 meters here, so we're going to be setting up the listening station in the privacy of the front garden, which frankly is preferable because staking out in a vehicle full of electronic test equipment is quite suspicious. Okay, so we are outside at our detection station. Now, just for good measure, I brought my old Agilent ESA out with me, just on the off chance that it may somehow be better, but I couldn't actually detect anything with it whatsoever, so that was a bit of a waste of time. So we're going to be sticking with the Siglant. Now, we have some prior intelligence that the occupants of this property here have a track record of watching test cards without having paid their dues. So we're going to see if we can catch them red-handed. Well, this is hard to believe, but despite being set up 20 meters away from the front of the house, we have a local oscillator tone. It is so ridiculously faint. It is noisy, it's messy, but that's clearly it. And I can prove that if I just go and change the channel on the TV. So there we go, I've just changed the channel to something else and it's gone, we got nothing. So let me just go and change it back again. And there it is, back again. And just look at the amplitude of that. I mean, we're down at sort of negative 130 dBm here. That is such a minuscule amount of signal that I'm frankly astonished that we can actually detect it. And it's not really very clean, but it's definitely there. We know what we're looking at. Well, I think we have confirmed that the mechanisms that these vans are stated to have been using are indeed plausible, but there are some big ifs here, and the biggest one of all to me is setting. So we are testing this in an ideal area. It's a street of detached houses, nice space between each one, minimal population, minimal vehicles, minimal appliances. It's perfect setting for this kind of stuff. And according to post office journals, this is the kind of setting they describe the vans operating in, but in reality it's not going to be the case. You're occasionally going to be in areas which are more densely populated, houses closer together, more cars, more people, more stuff. I think it would be a lot more difficult in those settings. And heaven forbid you were in a street where there are a lot of apartment blocks. I don't think you would come away with any useful information in that kind of setting. Now, the other big if for me is signal strength. So as we saw, even with that highly directional, high gain antenna, we were picking up negative 130 dBm from that local oscillator, which is just nothing. If there's any non-technical viewers still watching, that this is like grain of sand on the beach level of signal. However, according to post office journals, a lot of credible research was done on this, credible things written by credible people. So we have to assume that they must have found a way to do this with 1980s and even earlier technology. Anyway, as promised, we are going to go and have a look at that van we saw in the opening scene. Now, the staff on hand didn't know anything about it other than what I could see on the plaque, which was that it was built in 1983. From my look at it, it looks like a local oscillator detection van. Certainly it is of that kind of vintage, but aside from that, I don't have any more information, unfortunately. So let's go and have a look. Well, I'm inside the van now, and the first thing that jumps out at me is just how little is actually in here. There's basically just one chair and this very simple console. But one of the first things you really kind of notice when you're in here is just how many windows it has. I mean, I almost feel a bit like the Pope here. I feel really like I'm on display. Anyway, let's have a look at all of the various stuff in here, because there isn't actually all that much to look at. A little set of cupboards here, and presumably this is where the operators kept their sandwiches. Yeah, not really much in here, and nothing in there either. So, okay. And we seem to have some sort of mysterious equipment down here. Danger, high voltage. Let's see if we can get in there. Ooh, whatever was in there clearly has already been sold to the scrap man. Inverter, 240 volt output. So maybe that was just the power supply in there for the equipment on the console. And this here, also empty. Huh, that's disappointing. I'm very disappointed about that. What does it say? There's a little note in there. Please spray me. So the only major thing in this van really is this little console here, and this is a far cry from an outside broadcast van, for example, which is packed full of equipment and controls. In our detector van, we've just got this. This is very much the poser's van, I suppose you might say. Now, having a look at the actual controls here, I think I can kind of understand what they're doing. So this here looks to be some kind of specialized spectrum analyzer. So we've got a coarse and fine-tune gain and dispersion bandwidth, so that'll be like an aperture selection. We can see that there's indications of aperture there, normal and narrow. So it's a kind of more primitive version of what we were looking at on my spectrum analyzer, but probably more specialized for this application. And we can see up here we've got some LEDs which are indicating probably which antenna it's switched to, so I'm presuming we're going to find an antenna switch somewhere in here, maybe. Then we've got this 624 monitor. This is a Tektronix product. Now, Tektronix and other manufacturers used to sell their CRT displays just standalone, so this product would probably also be sold as a vectorscope, but this will just be one with all the electronics stripped out, and you can just use it for whatever you want to build some sort of custom piece of test equipment. So that's all that is. Now this one over here, I'm not certain what this is, so we've got two controls: range, cursor shift, pan, recorded, start house marker, recording, pan, recorded. I don't know. This is something very specific to the detector van. My guess, just looking at the controls here, it's something to do with how the van is capturing its work. So if they find a property that's evading their license, maybe this is where they go to somehow record the offense. I don't know. I'm sure I'll find out eventually, if by my own research, or maybe one of you guys know, I don't know. So that's all there is to see on this console. Let's see if there's anything else in this van. According to operational descriptions of older vans, this panel was likely part of a mechanism whereby vans were able to build up a plot of signal strength as they drove down the street. By pressing the house marker button, a graticule was created, which was then overlaid onto the plot. This would have given the operator a much clearer picture of what was going on in the immediate area, and a clearer indication of where an offending set was likely to be located. But anyway, back to the tour. And just in case you were wondering, that control there is just the air conditioning. Sorry about that. It's a little awkward to film this, but we do actually have some stuff down there. We've got a console emergency switch. Whatever kind of emergency that is intended for, I'm not actually certain. We've got an aerial switching unit junction box with a assembly number on there of some sort, if anybody knows what that is. There's definitely some stuff in here. And looking under the seat here, you can see the back of our Tektronix monitor, so that definitely is real. But yeah, not a lot else in the way of wiring or anything there. It's, it's very, very sparse indeed. So there is one of our antennas. It's a rather interesting design. So they do look similar to a Yagi antenna, but notice that each one actually has two cables coming off it. And then we've got two of them. Looks like two identical. So I don't know exactly how these actually work, but they do, this presumably is something to do with the directionality of them. Now looking inside the van, I don't see anything here which would indicate that these get rotated. So however they do the directionality, assuming they do anything, it must all be being done electronically. Well, having sat in this van and looked through it, my conclusion is that it's basically a glorified spectrum analyzer on wheels, and it would be interesting to know how good it actually was, but unfortunately we will probably never find out because it looks like at least some of the equipment has been removed. Well, a massive thanks to the Postal Museum for letting us in here to have a look at this van today. Now, one thing that's really stuck with me on this journey is that wherever these vans went, they would have been an unwelcome presence. And working in any kind of technical discipline can sometimes leave people feeling pretty unwelcome, but this would have been a whole nother level. And I do kind of feel for the people that had to work inside of these things. It wouldn't have been a great job. Now, I don't know about you guys, but I think I would probably rather be driving one of the red vans myself. But anyway, that is all today, and as always, thank you for watching.